welcome back. Today we will discuss about the algorithm that is called first come first serve. What this algorithm means? This algorithm means that the process which come first in a ready queue will get first schedule. Okay, so there are basically, let's suppose, four algorithm: 1, 2, 3, 4. This come at 0 second, this come at 2, this 3, this 4. So which algorithm get first 0, then 2, then 3, then 4? Now how the scheduling happen? The first algorithm first arrive first serve. Okay, but you have one very important question: what happens two algorithm arrive at the same time? That is very important question. Suppose P2 and P3 come at 2 seconds. So which algorithm go first? The algorithm which have process ID is smaller process ID. Here P2 has a smaller process ID, so first P2 go. So if there are two algorithms, so which algorithm goes first? The algorithm which has a smaller process ID. I hope you understand. This algorithm is very simple, easy to understand. Okay, but there is a very big problem in this algorithm, that is called convoy effect or starvation. What is that? So let you assume that there are three processes, A, B, C, all arrive at a, or you can say 0.001 second, 0.00002 seconds. So we assume that all arrive at a 0 second. Okay, and these algorithms follow this way: arrive at 0, the first algorithm goes and complete its work in 10 seconds. Second algorithm also complete its work in 10 seconds. Third algorithm also complete its work in 10 seconds. So what will happen? The turnaround time of first algorithm is 10 seconds, because it enter at 0, exit at 10, to 10 seconds. Second process 20 seconds, because it also enter at 0 or exit at 20. Third 0, exit at 30, to 30 seconds. Okay, now waiting time is enter at 0 and do not have to wait anything, or you can say turnaround time minus brush time. Every algorithm has a brush time of 10 seconds, so turnaround time 10 minus brush time to 0. Turnaround time is 20 seconds and brush time is 10 seconds, 10 seconds. Turnaround time is 30 seconds, and how much time is executed or in CPU of brush time? 10 seconds, so here is 20 seconds. Now average turnaround time is here 30 plus 20 plus 10 divided by 3 is 20 seconds. Okay, or average waiting time is 10 seconds. Okay, but there is a very big but, that is, what happens if there are three algorithms? Okay, they all arrive at 0 second. Okay, but they have this type of scenario: arrive at 0, but first algorithm A take 100 seconds, second take 10 seconds, third take 10 seconds. What happened? Their turnaround time is 100, 110, 120. I hope you understand how I calculate turnaround time. And waiting time is, here it take 100 seconds, it take 10 seconds to complete, it take 10 seconds. So 100 minus 100, 0. 110 minus 10, 100. 120 minus 10, 110. Now here 210 divided by 3 is 70 seconds of waiting time, and 330 divided by 3, 100 second of turnaround time, average turnaround time. So convoy effect says that in first come first basis, if the first process take lot of time, then other process has to wait lot of time, and that is very bad, because if this algorithm complete first, then the average waiting time may decrease by very much last time. So starvation or convoy effect says that in first come and first visit, this is the biggest disadvantage, that if the first algorithm take lots of time, then other algorithm have to wait till the first does not get completed. So this is the biggest disadvantage of this algorithm. I hope you understand. Now we will going to solve two very good questions, and please remember these are very good questions. So please see carefully these two questions, because these questions are very important. Please read the question I in that is present. So we make the table. Okay, so on the 0th second P0 come, okay, and it happened for 10 seconds, okay, so P0, okay. Sorry. Now at the 1 second P1 come, so the next algorithm which goes according to arrival time is P1, and it is for 6 seconds, because it takes 6 seconds, so 10 plus 6 16 seconds completed. Now next algorithm is P2, it is for 2 seconds, to here 18. Next algorithm is P3, it is for 4 seconds to 22. Now we find the turnaround time and waiting time. In every question you have to find the same thing, not a different thing, okay. Here the turnaround time is P1, P0, P1, P2, P3. So turnaround time of P0 10 minus arrival 0, 10 seconds. P1 16 minus 1 second, arrival time at 1 second, 15. P2 18 minus 3, 15. P3 22 minus 5, 17. Now waiting time is turnaround time minus brush time. Brush time of each of the every question is given here. So 10 minus 10, 0. 15 minus here 6 to 9. Okay. Now 15 minus 2 is 13. 17 minus 4, that is also 13. So what is the average turnaround time? Average turnaround time, that is 10 plus 15 plus 15 plus 17, that is 57. 57 divided by 4, that is 14.25. Average waiting time, that is 13 plus 13, 26. 26 plus 9, and it is for 35. 35 divided by 4 is equal to 8.75. 35 divided by 4 is equal to 8.75. So I hope with this example you find the average turnaround and average waiting time. And next question is very tricky and very important question. So hopefully you will see that question in very careful manner. So let's assume, okay. Please read the question carefully. Please read. I give you 2 seconds to read the question carefully. I hope you read the question carefully. Now let's start. First process which enter according to you is, which is the first process? It is P3, because it is at 0 second. So which process first enter is P3 at 0 second and exit at 2 second. Okay. Now another process which enter is no process arrive at a 2 second, and next process which arrive is at a 3 second. So 1 second is gap. CPU does not work here. CPU utilization decrease here. Now at 3 second which process arrive? P1, and it is for 4 second. So it goes at 7 second. P1. Now there are all processes come 5 second, 4 second, 4 second. Now which process goes? It is P5, because it arrive at 4 second. So it goes for 3 second. 3 second to P5 goes for 3 second, is become 10 second. Now there are two processes which enter same time, P4 and P2. So which process enter first? If there is a tie, the smaller process ID will get. So first P2 go for 3 second. So it become 13. Now P4 goes for 1 second, it become 14. Now turnaround time and waiting time. Okay, here P1, 2, 3, 4, 5. P1 turnaround time is, it exit at 7. Okay, P1 exit at 7 and enter it at 3. So his time is 4 seconds. Similarly P2 exit at 13 and enter at 5. So its time is 8 seconds. P3 exit at 2, enter at 0. Its time is 2 seconds. P4 exit at 14 and enter it at 5. So its turnaround time is 9 seconds. P5 exit at 10 and enter at 4. So its time is 6 seconds. Okay. Similarly, now find the beating time. Beating time means 4 minus burst time of this question. Burst time is 4 to 0. Similarly, for all other questions, 5, 0, 8 and 3. This will happen. Okay. Now find the average. So average turnaround time. Average turnaround time is 4 plus 8, 12, 12 plus 2, 14, 14 or 9 plus 6, 15, 15 or plus 14, 29. 29 divided by 5. 29 divided by 5 is equal to 5.8 second. 5.8 second. Now waiting time. 5 plus 3, 8, 8, 8, 16. 16 divided by 5. That is 3.2. I hope you understand this question. In this question, we note the two different things. First, if there are two processes which come at the same time, the process ID with a smaller process ID will enter first, like P2 and P4. P2 enter first. Okay. Second, if there is a no process, then at that time CPU is ideal, like these two questions. I hope with these two questions and other my concept, starvation and convoy, you understand each and everything in very careful manner. Please go and solve lots of questions. If you find any difficulty, please comment below and solve lots of questions. I hope you understand how this question gets solved. In next video we will solve another algorithm question. Till then, goodbye.